Hi children, now let's continue with the same problem. Find the smallest square number which is divisible by each of the following numbers 6, 9 and 15. It should be divisible. It means it should be a multiple of 6, 9 and 15. Only if it is a multiple then it will be divisible. Both are reverse process. So I am going to find the least common multiple for the numbers 6, 9 and 15. Just now we saw about how to find this LCM, and you all know the product of all these factors 2, 3, 3 and 5 will be the LCM of 6, 9 and 15. If I multiply 2 3s are 6, 6 3s are 18, 18 5s are 90. Now this 90, is it a square number? Is it a perfect square number? Is it a perfect square number? Just look at these factors. Are they all occurring in pairs? No, they are not occurring in pairs. 2 and 5 don't have pairs. So I cannot find the square root of 90 and it is not a perfect square number. Is it clear? Okay children. So to make this 90 a perfect square, what should I multiply with? I should multiply by 2 and 5 so that it will be a perfect square number. So 90 should be multiplied by 10 to get a perfect square number. So the required square number is 900. This 900, this square number is divisible by 6, 9 and 15 and it is the smallest square number. Is it clear my dear children? Okay, now let us get into next question. The student of class 8 of a school donated rupees 2401 in all for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. What do you understand from this question, my dear children? There are a certain number of students in a class. Each one have given their contribution. If there are 30 students, each student has contributed 30 rupees. If there are 100 students, each student has contributed 100 rupees. Do you understand the situation? This is how they have donated amount. Total, what is the total amount they have collected? It is given in the question as 2401. As I gave you examples now, 30 students gave each 30 rupees. So it should be 900 rupees only. 30 into 30, 3 3s are 9, 900 rupees. If each one has donated 100 rupees, there will be 100 students. Even then, 100 into 100, 10,000 rupees. So it is somewhere between 900 and 2400. So do you understand? This number occurs in pair. If I find the product of those two numbers, number of student and the amount each donated, it is going to be a perfect square number. And that amount is given to be 2401. Okay, this 2401 can be written as product of two same numbers. So what should I find now? Should I find the square or should I find the square root? I want to find the number of students in the class alone. They have given the total amount. So I should find the square root. Very good children. To find the square root, we can go in for same prime factorization method, and I found it to be 1, 2, 3, 4, 7. Product, it is a product of 4 sevens. So to find its square root, I consider 1, 1, 7 for each pair. So for this 2, 7, I will get 1, 7. For these 2, 7, I will get 1, 7. So I get 7 sevens are 49. So how many students are there in that class? 49 students. What is the amount contributed by each student? Again, it is rupees 49 rupees. Is it clear, my dear children, how they have contributed? Why we found the square root in this situation? So we come across the square root in our day-to-day life problem also. Now you should be capable of analyzing the situation. Okay, so now let us find one more property among the square numbers. Okay children, now here I have 2 digit. The number has 2 digit and its square has 3 digits. What is the square of 31? 961. And this is a 2-digit number and its square is 961. Similarly, the number 32 has its square has 4 digit. 32, 4 digit. So 3 digit or 4 digit. If the square has 3 digit or 4 digit, the number will be of 2 digit only. So I can have a conclusion, if the perfect square number has 3 or 4 digit, surely its square root. If I find the square root of 100, it will be 2-digit number. If I find the square root of 961, it is 31. So it is again a 2-digit number. So with the number of digits in a perfect square, I can decide the number of digits in its square root. Similarly, if I know the number of digits in a square root number, I can guess the number of digits in a perfect square as 3 or 4 digit. Is it clear, my dear children? Have a look at this table. After 2 slides, I will ask one general question from this. 10 squared 100, 31 squared 961, 32 squared 1024, 99 squared 9804. Okay, children? Now you should be capable of saying the number of digits in square root without actual multiplication or actual calculations. Okay. Now here's a question for you. With these examples, now we are going to generalize how many digits are there in the square root number, square root of a perfect square number. If it is 3, it is 2. If it is 4 digit also, it is a 2-digit number. Okay, half of this number. But for 3, I am going to add 1 and then it is half of it. For 5 means 5 plus 1, then half of it. Then 6 means half of it. So, I can generalize it as, if a perfect square is of n digit, that perfect square number is n digit, then its square root will have n by 2 digit if n is even. That is, if it has 4 digits, its square root will have only 2 digits, 4 by 2 digits. If it has 5 digits, 5 plus 1 by 2, because 5 is an odd number. So I have to convert it into an even number by adding 1 and then considering its half of it. Understood, my dear children? This generalization you may have it in your 1 marks or in MCQs. Okay, now let us see few examples using these two formulas. Okay. Find the number of digits in the square root of each of the following numbers without any calculation. This is the square number, perfect square number. Isn't it? 144 is a perfect square number. We all know this because it's a very simple number. 12 into 12 is 144. How many digits are there in 12? Only 2 digits. But I did the calculation now orally. But you should not do the calculation. Just by looking at the number of digits, you should say me the number of digits in its square root. Okay. So 3 digits are here. So 3 is an odd number. So 3 plus 1 is 4. 4 by 2, what will I get? 2. So the square root will have 2 digit in its square root. Is it clear? Now next question is, how many digits? Do I know the square root of this number? I have to do prime factorization or any other method to find its square root. But without doing that calculation, how can I find the digit in its square root? How many digits are going to be there in its square root? Now 1, 2, 3, 4, 5 digits are here. So for what is 5 plus 1? 6. 6 by 2 is 3. Very good. The square root will have 3 digit. Is it clear, my dear children? 3 digit in square root. 3 digit will be there in the square root of this number. Okay, children. Now I am going to ask you small simple question. Hope you will be able to do it. Have a look at this table once again. What is the square root of 100? 10. Square root of 961, 31. Or you can say square of 10, 100. Square of 31, 961. 32, 1024. 99, 9801. These are all 2-digit number. Okay. Based on this, I am going to ask you 2 questions. The question is, Which is the smallest 3-digit perfect square number? Which is the smallest 3-digit perfect square number? And I should be capable of finding the square root for that number. And it should be 3-digit. That perfect square number should be a 3-digit. Which is the smallest 3-digit number? 100. Is it a perfect square number? Yes. So the answer is 100. And its square root is 10. Okay, children. Now, this question you should think and tell me. You have to answer me. Which is the greatest 3-digit perfect square number? Come on, recall the box that I showed you now. Which is the 3-digit perfect square number? And what is its square root? Got the answer? 961 is the greatest 3-digit perfect square number and its square root is 31. Okay, likewise, you should be able to answer the greatest 4-digit perfect square number. And greatest, is it possible to have 1000 as a perfect square number? No, it has 3 zeros, odd number of zeros. A number with odd number of zeros cannot be a perfect square. Okay, so you should find the 3-digit smallest perfect square number. Okay, children, and these are your activity to be done at home. Think and get the answer for greatest 3-digit perfect square numbers. Sorry, greatest 4-digit perfect square number and smallest 4-digit perfect square number. Okay, children, now let us see what are the activities that we have to do for today's work. In exercise 6.3, you have to do problems 5, 6, 8, 9 and 10. This 5 and 6 you will have more subdivisions, children. You can do any 4 subdivisions. That's more than enough. And 8, 9, 10 are word problems that we have seen in today's video. It's of same model but the numbers are different. You have to practice it in your homework note. As usual, you will do all the examples and the problem that is there in the slides in your classwork note. Almost I have taken only the example sums to be in videos. So complete all examples in your classwork and all these problems in your homework note. With this, let me complete this session, and tomorrow or next session we will have a new concept to be learned. Okay, children, thank you. Take care, stay safe and stay healthy. Bye bye.